Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today we have got Rahul who has completed the course Linux Basics for Robotics and he'll be giving us a presentation on that. So what I'm going to do is I'm going to hand over the platform to him and he can begin his presentation. Alright Rahul, whenever you're ready.
Sure. So, hello everyone, and today I'm here to demonstrate my presentation about how I made the ROS about the Linux basics for ROS.
Mm-hmm.
And yeah, I'll start with the my slides presentation. So I'll just make
Just
it a full
remember you
screen.
have to keep track of time so you
Is it
don't run
visible?
out of real robot presentation.
Sure, sure, sure. I'll keep that in mind.
Yeah, we
Sure.
can see it.
So thanks. So this is basically the um, our platform where we will be demonstrating about the naive obstacle avoider, and we will also see real-time robotic statistics, and then we will go on to the bash scripts to see how everything works. So here we have the project objectives. Like the project which I did was it was basically in part one, I think it was file system navigation, and in part two, it was basically bash function library, creating a bash function library which sets the getters and setters.
Mm-hmm.
And in the part three, I was asked to make obstacle avoidance script and a robot statics script.
Mm-hmm.
So this is how everything will work. Like we have created bash scripts that will communicate with the Python file, which sets the parameters and topics to communicate with the robot. And this is our robot functions dot bash library, which I was talking about in our part two project. So here the core methods are basically three methods, actually two methods, the getters and setters. So what we have here is get robot values. So we will get, as you can see here, that we will get the robot's values, like what is its surroundings and how far it is from the obstacle, and all those values, its odometry values, and then we will analyze those values and set its angular and linear velocity.
Mm-hmm.
So there are the setter commands also in this robot.functions bash script. So this is basically the workflow of our code. So here, as you can see, we will collect the data from the getters, and then we will safety check accordingly the data. Like here, I have put 0 0.3 meters. So if this threshold is touched, like if any obstacle is below this uh, um, threshold, then it will take a decision to compare to move left or right, and then it will execute the according methods. So this will be the our more statistics file. It will tell us the coordinates, direction, and cumulative distance. This is how it will show us. And so yeah, the we can start with the demonstration, shall we?
Yes, let's go.
Okay. Sorry, I was okay. So yeah, we can go ahead and connect our real robot.
Mm-hmm.
It will take some time. Until then, we can set up. Okay. So yeah, we are connected. So I would like to just mention it. Uh, we were basically needed to go again and again on the same path. So I just added its path to the bash src script.
Hmm, nice.
So whenever I launch my new terminal,
Maybe you can
it
show
will
us
launch it
again.
on the same path. Oh, sure.
Yeah.
So we will move to CDA tilde ash. Uh, okay, now here we can see ls dash la. So as you can see, okay, sorry, la. Sorry. Here you can see we have our bash src file. So we are going to be edit this one. And for that, we will use the V editor.
Mm-hmm.
Okay, so it's open. So here we can edit this in the V editor by commanding it from Shift I.
Mm-hmm.
So now the insert uh, mode is activated. And let me go to the bottom of it so that we can see the line which I added here. Okay, so here is the line which I added to, every time I launch a new terminal, it will so basically what happens is whenever I launch a new terminal, it source the bash rc file.
Mm-hmm.
So since this line is also available in the bash rc file, it will execute this command also.
Mm.
So what it does is it basically uh, takes us to this linux basics project with this cd command. uh, yeah, so this is how I did it.
Very nice. So it opens your terminal will open by default on in that directory. It's no longer using
uh, yeah.
okay. Very nice. Thanks for bringing it up. It's a very nice, handy way of handling things that you do repetitively. All right, let's go on to our demo.
Okay, so first of all, we will need to launch the. So what I'm gonna be doing is, first of all, I have to go to the same directory again.
Mm-hmm.
Uh,
Maybe you can just open another terminal to see if it works well.
I remember the path. I just remember the path, so it will not take much time.
Okay.
So yeah, we are in the same directory now, and
Mm-hmm.
which is okay. So now we'll wait for 5 seconds to be okay. So it's ready, as we can see here. And now we can launch our obstacle avoiding script. Uh, um, okay, let me make it. So as you can see, we have got all the 5 values, and since the front left is free, it will turn right side. Okay, it's moving forward. Okay, oh, so this is the new data where everything is clear. Uh, so yeah, here we can see front left is free, so we will move right. Since here all the sides are free, we will move forward. The robot will move forward. Okay, here front right is free, so we will again move left side. Okay, so I think I have, yeah, I think it's working fine. Misunderstood the, um, you know, eco code.
Mm.
So yeah, everything is working fine. Since all these sides are free, like front left, front free, front right, it was moving forward. And if the front free is not the front is not free, then it will compare the front and left values, and which will be whichever will be more greater, it will move in that side only.
Mm-hmm. Mm-hmm. Yeah, it's doing
As you
well.
can see, it has calculated exact distance. I would like to demonstrate one more bash script which I have created, but
Mm-hmm.
it has a lesser code, it has lesser loops. Basically, it does the same thing,
Mm-hmm.
but I think it is more optimized according to me. I'm not sure if it is or not.
This one
I'll
seems to be
demonstrate, I'll explain the code later.
okay. Sure, sure. This one
Yeah,
seems to
yeah,
be doing
sorry.
well, so I'm quite keen to see what the other one will do, and maybe you can explain what you think
Okay, so should I just first launch the statistics file, or just head to the my um, my custom bash script?
Let's see your custom one first. I believe it also can give us
Okay,
statistics values, right?
yeah, it
Yeah,
can.
so we can run it on that one.
Okay, it has to stop. I have, you know, okay, it has crashed. I have, closed the script in a wrong time. It was moving forward, and I closed the script. Okay, so I think I have to first move it a little bit back, and then I can launch my custom script.
No worries, yeah.
We have to relaunch this robot interface for that also.
Mm-hmm.
Uh, it what was its name? Okay, its name was testing robot bash. So basically, it will do the same things. You will see the same behavior with in the real robot,
Mm-hmm.
but the difference is how I designed the logic, which I will demonstrate while we see on to the editor part.
All right.
So as you can see, it is also doing pretty fine, but it has a minute difference that if our previous script was doing, if the front left is free and the front right is not free and
Mm-hmm.
front is also free, then the previous script will move the robot to the left side. But in this case, we will, just move ahead. It will not, uh, because the front is free, we have enough room, so we will just move ahead only. So that was a minute difference in the logic, but the structure is also different. So that will I will demonstrate while move to the
Okay,
scripting part.
so you're saying that what was the previous one doing, right? The original one was also moving forward when the front was free. So I'm not the way you explained your difference. Maybe give it one more attempt
I can show you. I can show you with. So-
with the code. Yeah, it's fine.
Sorry,
It's fine.
I think your stream is freeze.
Okay.
Okay.
You can hear me now.
Should I launch the statistics file? Then we can move ahead, and I can explain everything
Yes.
in that part.
Okay. All right. You can hear
Yeah,
me
yeah, I
clearly,
can.
right? You can still hear me, right, Raul?
Yeah, yeah, I can.
Okay, good. So yes, launch the statistics script and then you can go to the code.
Okay, sure. Okay, so here I faced a challenge. One getter function was unavailable, which was IMU getter, IMU angular velocity and IMU linear velocity,
Mm-hmm.
linear acceleration. So these two getter functions were unable in our in the project. So I did a digging and I saw that it was all commented in the Python script. So for this one, I just uncommented all those IMU getters and created all those mm, uh, getters and just did the what the project was asking.
Yeah. Do you understand why they were commented out at least?
I thought that the other robot, the simulation one, doesn't have the IMU values. But it was mentioned, I think, that the fastbot does have IMU
No, this one no.
values.
This one is the first part. So it's
So
not the
I
fast part.
thought that I should at least try and. Okay, okay, okay.
Yeah. So
So that is
so
why
if
it is showing, I think, zero and zeros and zeros.
yeah, stop
Okay,
execution
I
and
understand, sir.
then get into the neat details you spoke about earlier.
Okay. So should I disconnect the robot or we will?
No, it's fine. We can disconnect later.
Okay, let it be connected, and
Yeah, just make sure
first
it's
we
not
can.
running. Yeah.
Okay. So here, what I was talking about, the Bash script, which had all the methods for getters and setters.
Mm-hmm.
The IMU getters were not present, so I just mimicked all these methods and just put their IMU names, IMU getters and setters names here,
Okay.
and created all these six methods. So should I just move to the obstacle and my custom script, or
Yes. Yes.
okay, okay. So I'll just first explain the obstacle avoider script,
Mm-hmm.
which is the project, and then I'll move ahead and explain my own script.
Mm-hmm. Okay.
So first of all, here we have this first line, which is, so first of all, the first line is this user bin bash. So what it does is it basically tells the terminal that it is a bash script. It's called shebang line. And after that, we have this source.robot.bash function.bash. So it basically does what it does is it sources this file robot functions, which we saw here. All the getters and setters values will be imported in this file also, which
Mm-hmm.
it will be available here also, which we will use in later in the code. So first we have printed these two lines like running naive obstacle avoider with bash script. Press Control C to terminate.
Mm-hmm.
Then we set the with these two setters, we set the linear and angular velocity to 0 to make it static.
Okay.
And then we stored this 0.300 value to this variable named threshold,
Mm-hmm.
which we will use later in the code.
Mm. Okay.
So now our while loop starts. It will, I'll explain why I put this one into. So these are the five variables like LL range, FL range, FF range, FR range, and right range.
Mm.
So right RR means extreme right, LL means extreme left, and FL means front left, front and front right.
Mm-hmm.
So what these variables will store is they will execute this function. They will get the values of this function, the getter functions, and store their values into themselves, which we can use in our code.
Mm. Okay.
So these are the five values which we were printing during the live demonstration.
Mm-hmm.
So here you can see I have echo front right range, and here we are injecting the value and putting a meter ahead of it. So this was the code which was printing all those five values. Then here there are other three variables which will basically store binary values. They will just compare these front left, front and front right range values to the threshold which we have set here, which is 0.300, which is basically zero point 0.3 meters. And it will the bash terminal does not compare float values on its own. So we have used this calculator method, which is bc dash l, and bc dash l we have to the pipe string into it. So we have converted this whole line into a script, into a string using the echo method, and then we have piped into the this one, and then whatever came out we just stored in the front free through this dollar sign. So it will return only 0 or 1. So if the front range is greater than threshold, it will give 1, and if it is not, it will return 0.
Mm-hmm.
So these three variables store 0 or 1, 0 or 1, so which we can compare. So here our main logic starts. Till now we have only defined and stored variable names and all.
Mm.
So here our main logic starts, which is we have put many conditions here. So the first condition is that it will compare the front left free, which is FL, which you can see here, the front left free,
Okay.
the front free and the front right free. It will compare all these values and see if any of these variables have 0 or 1.
Mm-hmm.
So 0 means that it is below the threshold. So that means it has an obstacle on all those three values.
Mm-hmm.
So it will, what it will do is it will just first it will compare the front left. If it is 0, then means here is also an obstacle. Then front, here is also an obstacle, and the front right, here is also an obstacle.
Mm-hmm.
So it will just satisfy this condition. Since we have put the and, so it will have to compulsorily check each compulsorily satisfy each condition.
Mm-hmm.
Since all these sides are blocked, it will then enter into this code, which will basically compare the extreme left and extreme right range
Right.
here through again this BC calculator. And accordingly, if it returns, if the left range is greater than the right range, it will return true. Then it will do the it will set the angular velocity to this value. And else, if it is not wrong, that means the right range is more, then it will set the angular velocity to minus. So minus means right side, and non-minus means left side.
Mm-hmm.
And it will keep set this value for 0.8 uh, seconds,
Okay.
and then it will set the angular velocity to 0 again,
Mm-hmm. Okay.
and then
So
it will again.
there is a lot of detail that you're explaining, and I like that you're getting into as much
Okay.
of it as possible. But we are running out of time, so let's go to the other
Okay.
script, your custom script, and you can tell us what
Okay.
exactly you changed.
Okay. So first I'll just show that how long is this script is. As
Mm-hmm.
you can see
Okay.
now, this is my script. This is my script. So until now, while we were setting the variables and storing values into it,
Yes.
it is same. After that, the logic comes. When the logic comes, so here I have just um, check for the front free.
Mm-hmm.
If the front free is not free, if we have obstacle in the front free, it will just compare for the front left and front right.
Mm-hmm.
uh, uh, just look at here, we have put an or operator. So if any of one is free, then it will enter into the loop and compare if the front left is has more range or the front right has more range, again through this BC calculator.
Mm-hmm.
So if the front left has more range, then it will move towards the front left range
Mm-hmm.
and front left. And if the condition is wrong, then it will turn towards the right range, front right range.
Mm-hmm. So
Okay.
basically, you
So
minimize
here, what I have done is if
you minimize the number of comparisons that it had to do in each case.
yeah, 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 yeah,
Okay, but go on. I
exactly.
wanna hear your part of the explanation.
Okay. So and then if this one also gives a if this one also doesn't satisfy, like if the this one also has occupied and the right one is also occupied, then we will go ahead and check. Since here I have put an else, so here it will check if the extreme left range has more room, or the right range has extreme right has more room.
Mm-hmm.
And it will again compare and just set the left or right command through this setters. So I have also for the front left and extreme left, I have differentiated with this sleep time. So I have put here 0.350 sleep time, and for the extreme left I have put 0.800 sleep time. So it turns for front left, it turns diagonally, and for extreme left or extreme right, it turns for approximately 90 degree.
Mm, mm. Very, very nice. I like the
And
way that you considered idea is to get as fine control as possible, right? And you have taken all that in consideration here.
Yeah.
So depending on who is free, you determine how long your robot has to turn for, right? So very, very nice. I
So
like this.
yeah. So this one code, this snippet is similar to the our obstacle avoider script.
Mm-hmm.
So as you can see here, also we have, it is basically to move the robot forward and how far it has to go. But
Mm-hmm.
I have done one minute detail here. I have added one minute detail. So what was happening is I was each time I was calculating the time I was subtracting 1 second from it, right?
Yes.
Here, as you can see, okay, sorry, we were subtracting 1 second from it.
Mm-hmm. And why is that? Can you explain that?
Okay, so for the buffer time, so when it sets to the robot, its linear velocity,
Mm-hmm.
it takes some buffer time. So we have taken, safe side for the, you know, I just can't recall that word. So
Okay, all right. Let's get
for the
into
safety
English.
purposes, basically, so that it doesn't. Okay. So basically, what I have done here is I have created one more variable named minimum time,
Mm-hmm.
which is 0.5. And if the time which we have here, if the um, time which we will get from distance to move upon 0.100, which is its velocity,
Mm-hmm.
if we will get below the 0.5, which is minimum time, so I have compared again this time to move. If time to move is below than minimum time,
Mm-hmm.
then it will contain minimum time in the time to move. So the minimum time, which was 0.50, uh, it will store it into the time to move.
Mm-hmm. What about
So what was happening is it was sometimes it was giving negative values for the time to move.
okay, okay.
So that was a concern. So to avoid that, I just did this logic, and
But does
yeah.
that not make your robot vulnerable to collisions though? Because now you are hard coding the time that it is to move, even though the information that you have been given is suggesting that there is an obstacle that is to
So
cross.
Uh, but here, as you can see, the distance to move is what we will get from the sensor.
Mm-hmm.
So any value that we will get, we will divide it by its velocity.
Mm-hmm.
Then we will get the actual time to move. And only if it is less than 0.5,
So that's like zero point 0.5 of a
sorry,
second, right?
1.5.
Okay.
So basically, yeah, zero point 0.5 of a
Okay.
second.
All right.
So
I think it's small enough, but you can think about this case as you go on, right? So it depends with how close the obstacle is, right? Before you set the minimum time to move. So
yeah,
I'm assuming you did a whole lot of testing to come up with zero point 0.5 as a safe
yeah,
time.
I did the testing and.
Okay.
Yeah, and it sometimes collided also, but I just optimized and I increased this 0.5 minimum time to I just put a zero point 0.3 timing
Mm-hmm.
previously, then I increased it to 0.4, then 0.5, and after that it didn't collide. So I thought this one is so I did the trial and error thing, and I thought I have
Yeah, yeah. You have to test for
yeah.
everything, right? Yeah, especially edge cases, because
So
you were
this was
already
the basic.
instead of optimizing what was already there, then you needed to pay more attention to edge cases, which I think is a very good attempt. So,
Yeah.
very job well done, Rahul. So,
Thank you. Thank you. Okay.
all right, everyone. This was Rahul's presentation, and wonderful job well done to him. And I'd like to encourage all those of you who want to try this course at least, or any other ones that we offer certification on, to do so. And you can also come and showcase your work and make this presentation or anything similar. Until